Ispod moga pranca, jutro zapleteno u visinama kao lice stranca. Naboralo se more u daljinama kao tempera. Kiša nebo oboji, takve je boje srce moje. Otkad me ne voliš, o kao tempera. Kiša nebo oboji, takve je boje srce moje. Otkad me ne voliš. Kada krenu zime i nakupe se alge na koritu i na moje ime, u zaboravu tvome duboku kao tempera. Kiša nebo oboji, takve je boje srce moje. Otkad me ne voliš, o kao tempera. Kiša nebo oboji, takve je boje srce moje. Otkad me ne voliš. Ispod moga pranca, o jutro zapleteno u dubinama kao lice stranca. Naboralo se more u daljinama kao tempera. Kiša nebo oboji, takve je boje srce moje. Otkad me ne voliš, o kao tempera. Kiša nebo oboji, takve je boje srce moje. Otkad me ne voliš.
Dame i gospodo, hvala vam najljepša na ovome pljesku za naše glazbenike koji su započeli na ovako lijep i dinamičan, a opet nježan način ovo naše svečano otvorenje. Pa pozdravimo još jednom ih velikim pljeskom, jer hvala im što su i službeno, dakle, započeli ovo svečano otvorenje. Naš poznati umjetnik na gitari, Mario Šimunović, i prekrasna, divna i talentirana Martina Majerle. Hvala vam lijepa, vidimo se mi još. Malo nam je drugačije nego prijašnjih godina, zar ne? Od samog ulaza do činjenice da nas je ovdje mnogo, mnogo manje. Stoga hvala svima vama što ste došli i dobrodošli u Opatiju Bajnu ukoliko iz nje niste. Dragi uzvanici, dragi naši gosti, svi vi koji pratite sve ono što MIPRO radi već godinama, vi dakle koji ste ovdje u dvorani, ali i svima vama koji nas gledate putem jednog od 10 kanala Zooma ili putem YouTube streama, a link ukoliko još niste našli možete pronaći u chatu za Zoom. Dobar vam dakle dan, doista jest dobar, zovu za vikend neko loše vrijeme, ali na svu sreću danas je osvanulo ovo lijepo sunce, posebice je lijepo vidjeti ovo sunce na Jadranskom moru kada se prođe kroz Gorski kotar i onu magluštinu ako ste dolazili iz smjera Zagreba ili bilo gdje istočno od rijeke. Dakle, dobrodošli na svečano otvaranje 43. Međunarodnog ICT skupa MIPRO 2020. godine. Malo je pomaknut, kao ostalom što je pomaknuto i sve. Dakle, drugačiji je termin, ali i način održavanja je kao što možemo i vidjeti i osjetiti, a već smo se nekako, nažalost, i navikli na sve ove okolnosti koje su nas zatekle, dakle i način je drugačiji od uobičajenog. Za sve nas koji smo ovdje u ovoj već tradicionalnoj dvorani, ovo svečano otvaranje održava se uživo, no dio će biti dakako i virtualno, kao što smo već i navikli ovih posljednjih nekoliko mjeseci. U organizaciji i brizi o vašem i našem zdravlju uvelike nam je pomogao Stožer civilne zaštite grada Opatije i na tome im velika hvala. Upravo zbog poštivanja epidemioloških mjera zamolit ću gospodu Franu Barbarića, Gorana Jovičića, Gorana Markovića, Emila Priskića, Marka Filipovića, Sašu Drezgića i Karolja Skalu da mi se pridruže odmah ovdje na pozornici gdje ih čekaju njihove bijele fotelje, stoga slobodno možete zauzeti svoja mjesta, udobno se smjestiti. Svako od vas ima svoj mikrofon, pa ću vas samo zamoliti da prije svoga pozdravnog govora isti i uključite. Poštovanje i dobar vam dan. Also, a piece of information for everybody who doesn't speak Croatian and is watching us online. There is a link for the translation, which also you can find in the chat of a Zoom channel you're currently using. Nije zgorega ponoviti i zašto smo ovdje i što je zapravo MIPRO. MIPRO je dakle najstariji, najveći nekomercijalni ICT skup ne samo u Hrvatskoj, već i u ovome dijelu Europe. Vrata MIPRA od samih njegovih početaka širom su otvorena svima koji djeluju u području informacijske i komunikacijske tehnologije i novih tehnologija općenito, svima koji kroče putem znanja i inovacija, putem koji vodi, znamo već svi, u budućnost. U našoj sredini svijest o značaju visokih tehnologija postoji od samih njihovih početaka. Ta svijest rezultirala je pokretanjem skupova MIPRO u gradu Rijeci sada već davne 1978. godine. Tada počinje priča o MIPRO koja traje do naših dana i vjerujemo da će potrajati još dugo, a upravo ovogodišnje izdanje u gotovo nemogućim okolnostima dokazuje da se neće tako lako predati. Na početku ovog svečanog otvaranja pozdravit će vas predsjednik udruge MIPRO, gospodin Vedran Mornar. Virtualno.
Želim vam dobrodošlicu na 43. konferenciju MIPRO. I vama koji ste fizički prisutni u dvorani i vama koji nas pratite onako kako se to danas kaže, nažalost uvriježila se ta riječ u hrvatskom jeziku, online. Jako sam ponosan što smo usprkos ovim nedaćama koje su nas zadesile ove godine uspjeli održati ovogodišnji MIPRO. Ne u naročito normalnim okolnostima, nažalost, puno bi bilo ljepše vidjeti vas opet u Opatiji, krajem svibnja i družiti se za vrijeme i prije i poslije konferencije, jer bit ove konferencije, osim njenih znanstvenih i stručnih sadržaja, upravo jest i druženje. Ali vjerujem da će i ovako konferencija biti zanimljiva za sve i da će svatko pronaći nešto za sebe. Ispričavam se zbog vlastite odsutnosti, ali nama je na FER-u krenula nastava i u vrijeme dok vi ovo gledate, ja ću predavati našim studentima. Naše je geslo uvijek bilo nastava ne smije trpjeti, možda je i zato FER ono što jest. Hvala vam svima što ste došli na ovaj ili onaj način i pozdravljam vas puno nade da ćemo se u svibnju sljedeće godine opet sresti onako kako treba u svibnju u Opatiji.
Hvala lijepa gospodinu Mornaru na ovim lijepim riječima. Doista vjerujem da svi imamo tu istu zajedničku želju da se ubrzo stvari normaliziraju i da se na ovakvim i sličnim skupovima družimo onako kako smo i navikli, bez mjerenja temperature, bez maske i bez bojazni da ćemo se zaraziti virusom. No, održava se konferencija, odnosno ovaj Međunarodni ICT skup i program nije manjkav, dapače. Međunarodni programski odbor MIPRA pripremio je dakle bogate znanstvene, stručne, tehnološke i poslovne sadržaje ovoga skupa. Ti sadržaji prezentiraju se kroz cijeli tjedan. Stoga ljubazno molim gospodina Karolja Skalu, predsjednika programskog odbora MIPRA, da nas upozna s njegovim bogatim sadržajem. Profesore, izvolite.
Hvala lijepo. Lijep pozdrav svima. Drago mi je vidjeti da je dvorana puna. Naime, u ovim uvjetima smo popunili dvoranu. Dobrodošli na najveći nekomercijalni ICT skup u regiji na 42. MIPRO 2020. U ime svih članova MIPRO-a iskazujem zahvalu i trajni spomen profesoru Biljanoviću za njegov doprinos zadnjih 4 decenije. Bio je odan u misiji i ideologiji da je MIPRO zajednica i simbioza znanja, gospodarstva i društva. Skoro bi rekli da je to od početka pojave mikroprocesora u MIPRO-u vodeća ideologija spojiti tehnologiju sa napretkom i razvojem. U tom svjetlu će nam ostati profesor Biljanović u trajnom sjećanju. Tehnologija preuzima glavnu ulogu u oblikovanju društva i života danas. Gledamo na našu misiju iz kuta naprednog tehnološkog progresa te uslužne infrastrukturne pozicije i društveno-socijalne odgovornosti. Sa stanovišta ICT-a ova godina je u tom pogledu posebno značajna i iz više razloga. Važan čimbenik je pandemija COVID-19 koja je otvorila nove dileme i ugroze koje nas ujedinjuju i usmjeravaju. Od istraživanja u prirodnim, tehničkim i društvenim znanostima se očekuju značajni doprinosi u razvoju optimizirajućih preokreta u razvoju tehnologije i okoliša prema suvremenom i stabilnom informacijskom društvu. Naglašavam, informacijskom, a ne informatičkom. Sve to činimo sa našim brojnim pokroviteljima koji ove godine imamo. MIPRO želi postati čvorište i infrastruktura u svojoj programskoj orijentaciji i teži povezivanju sa sličnim ICT asocijacijama u Europi. Tako djeluje u simbiozi i suradnji sa tehničkim kosponzorima kao što se vidi na slajdu. Svjesni da uvjeti izazvane ove godine da ne možemo u potpunosti ostvariti sve naše želje i dosadašnju praksu, odlučili smo da virtualna tehnologija mora biti nužan dio naše programske provedbe. Tako održavamo hibridno savjetovanje, tradicionalno u Opatiji, uz mogućnost virtualnog sudjelovanja preko online konferencijske platforme. U tome smo dobili podršku naših sponzora, od kojih izdvajamo Hrvatsku elektroprivredu i Končar elektroindustriju kao zlatne sponzore. MIPRO ima veliki broj skupnih članova koji pomažu i podržavaju provedbu programskih segmenata. Ovim u ime programskog odbora zahvaljujem pokroviteljima, sponzorima i koorganizatorima na svestranoj pomoći, suradnji i podršci. Savjetovanje se odvija fizički u kongresnom centru Adriatic u hotelu Admiral te u cyber prostoru na 10 telekonferencijskim kanalima preko online Zoom platforme sa preko 2000 očekivanih učesnika iz cijelog svijeta. Program uključuje 14 konferencija, 8 pozvana predavača, 369 radova od 996 autora iz 37 zemalja. S time se pokrivaju skoro sva područja ICT-a i tako možemo reći da je MIPRO širokopojasna, hibridna, otvorena konvencija. Plenarna pozvana predavanja na ovom otvaranju su iz robotske tehnologije. Dr. Rainer Bischof iz Kuka Robotics firme iz Njemačke će održati predavanje Future of Robotics from Challenge to Innovation i profesor Guljane Moller sa Sorbonne sveučilišta u Parizu, Combining Human and Robotic Motion Control for Medical Devices. Sa veseljem vas pozivamo na tradicionalni koktel party koji će se održati u 19:30. U toku je objavljivanje poziva programskih segmenata za 44. MIPRO 2021. na kojima se ističe tematski fokus ICT u obnovljivim izvorima energije. Organizirat će se i prva regionalna konferencija Regional Hydrogen Energy Conference po planu kao do sada zadnji tjedan u svibnju naredne godine. Vidimo se na 44. MIPRO konvencije od 24. do 28. svibnja 2021. Dozvolite još jedan put da zahvalim svima koji su sudjelovali u ostvarenju programa. Želim svima učesnicima koji su fizički nazočni ugodan boravak u Opatiji, a svima ostalima uspješnu razmjenu informacija u cyber prostoru, odnosno na online konferenciji.
Hvala lijepa, profesore Skala. Hrvatska elektroprivreda godinama organizira tradicionalne seminare posvećene ICT-u, elektroenergetskim sustavima i regulatornoj politici, a suradnici iz HEP-a predstavljaju svoja stručna i znanstvena ostvarenja na savjetovanjima. Pozivam predstavnika zlatnog sponzora, predsjednika uprave Hrvatske elektroprivrede, gospodina Franu Barbarića, da pozdravi skup. Izvolite.
Mora se dužno držati. Sve u redu. Zahvaljujem. Poštovani predsjedniče, poštovani domaćini, organizatori, sudionici skupa, dame i gospodo, sa zadovoljstvom vas sve pozdravljam u ime Hrvatske elektroprivrede. Prije svega čestitam vama organizatorima na tome što ste u iznimno vrlo složenim okolnostima i ove godine na istom uobičajenom mjestu uspjeli organizirati skup MIPRO. Drago mi je da smo ponovno u prilici kao sponzori dati svoj doprinos održavanju ovog prestižnog događaja. Kada se osvrnemo na vrijeme proteklo između dva skupa, s ponosom vas sve mogu izvijestiti da je HEP u tom razdoblju pokrenuo pa i završio čitav niz projekata. Postavili smo više od 200 punionica za električna vozila širom Hrvatske. Nedavno smo u rad pustili sunčanu elektranu Vis. Još 6 sunčanih elektrana je u različitim fazama izgradnje, a pri kraju je izgradnja vjetroelektrane Korlat. U Zagrebu gradimo novi visokoučinkoviti kogeneracijski blok. Dovršili smo, nastavili ili započeli niz projekata u prijenosu i distribuciji električne energije. Zašto spominjem sve te projekte koji na prvi pogled nemaju puno veze sa glavnim temama i područjima koji se bavi MIPRO? Zato jer se u svakoj od tih elektrana i trafostanica ugrađuju sve sofisticiraniji uređaji za mjerenje, nadzor, upravljanje i obavljanje niza drugih funkcija, a koji su bazirani na suvremenim informacijsko-komunikacijskim tehnologijama i rješenjima. Spominjem to i zato da dobijete dojam o snažnom rastu opsega investicija u HEP-u posljednje 2 godine. Samo ove godine naše će investicije iznositi više od 4 milijarde kuna. To posljedično znači veću realizaciju u svim segmentima, pa tako i u angažmanu domaće proizvodnje i domaće pameti i u branši koje vi pripadate, poštovani sudionici skupa. Na kraju, podatke o našim investicijama u obnovljive izvore energije spominjem i u kontekstu najavljene konferencije o vodiku koja će se održati u sklopu idućeg MIPRA. To je dobar pokazatelj da su klimatske promjene i pronalaženje rješenja za njihovo ublažavanje danas neizbježna tema povezana sa svim aspektima znanosti, tehnologije i općenito ljudskog djelovanja. To je tema u kojoj smo svi zajedno i gdje smo mi u HEP-u prepoznali ciljeve i prioritete Europske unije. Zato smo i uspjeli u posljednjih nekoliko godina na nizu projekata osigurati sufinanciranje iz EU fondova u iznosu od oko 1 milijardu kuna. Time smo dali dodatni doprinos dobrim rezultatima vlade u povlačenju sredstava iz Europske unije. Izdvojit ću ovom prilikom tek nekoliko takvih projekata koji imaju blisku poveznicu s područjima koji se bavi MIPRO. To su pilot projekt uvođenja naprednih mreža u distribucijskom sustavu Hrvatske, Zatim, prekogranični projekt Synkrogrid u suradnji sa partnerima iz Slovenije, koje je Europska komisija proglasila najinovativnijim projektom u području naprednih mreža. Te međunarodni projekt Big EV Data, koji za cilj ima izradu odgovarajućeg IT rješenja za upravljanje punionicama za električne automobile. Osim u našoj glavnoj djelatnosti, električnoj energiji, inovativna tehnološka rješenja razvijemo i primjenjujemo i u ostalim djelatnostima. Tako je primjerice ove godine HEP Plin započeo proces digitalizacije upravljanja mjernim podacima, nabavom pametnih plinomjera te ugradnjem IoT senzora, što je trenutačno najveći projekt interneta stvari u Republici Hrvatskoj. U idućim godinama čeka nas niz novih izazova na kojem ćemo spremno odgovoriti. Jedan od tih je i priprema Hrvatske za uvođenje infrastrukture i razvoja usluga pokretnih komunikacija 5. generacije, a u skladu s aktivnostima vlade na ispunjenju akcijskog plana Europske komisije 5G za Europu. HEP će i na tom području znati pružiti puni doprinos. Na kraju, organizatorima i svim sudionicama 43. skupa MIPRO-a želim uspješan rad i realizaciju programskih ciljeva. Zahvaljujem.
Hvala lijepa gospodinu Barbariću i čestitke HEP-u na svim uspjesima. Končar elektroindustrije gospodarski je subjekt koji se pridružio MIPRO u njegovom pionirskom dobu koncem 70. godina, kada je MIPRO prvi kod nas sustavno promovirao ideju mikroelektronike, oličenje koje je bio mikroprocesor, sićušna silicijska pločica koja je u doslovnom smislu promijenila svijet. Gospodin Ivan Bahun, zamjenik predsjednika uprave, obratit će nam se u ime Končar elektroindustrije, zlatnog sponzora i suorganizatora skupa. Nadam se da ga imamo na liniji.
Poštovani sudionici skupa MIPRO 2020, čast mi je i zadovoljstvo pozdraviti vas u ime Končara, zlatnog sponzora 43. Međunarodnog skupa MIPRO i u svoje osobno ime. Ovaj međunarodni skup za informacijsku, komunikacijsku i elektroničku tehnologiju ima vrlo važnu ulogu u promicanju znanja i novih tehnologija te u oblikovanju društva i života općenito. Sve to je i u fokusu društava grupe Končar. Glavna područja našeg djelovanja, oprema i sustavi za energetiku i transport, snažno su izložena izazovima digitalne transformacije, a ovaj skup se upravo bavi njezinim glavnim temeljima. Končareva suvremena rješenja u elektranama, prijenosu i distribuciji električne energije, modernim tramvajima i vlakovima primjer su primjene suvremenih informacijskih, komunikacijskih i elektroničkih tehnologija, a sve sa ciljem da kroz digitalnu transformaciju i suvremene sustave damo svoj doprinos u održivom i ekološki prihvatljivom razvoju društva. Neka od tih rješenja prezentirana su na ovom savjetovanju kroz radove naših zaposlenika, ali i kroz prezentaciju pod nazivom Digitalna platforma grupe Končar. Pandemija uzrokovana virusom COVID-19 razlog je za ovogodišnji hibridni oblik održavanja savjetovanja. Mogućnost hibridnog održavanja savjetovanja pokazuje veliku važnost i snagu suvremenog ICT-a i digitalnih tehnologija. Upravo ova neželjena pandemija silom prilika je ubrzala i približila primjenu novih tehnologija. Ono za što bi možda trebalo nekoliko godina, dogodilo se u nekoliko mjeseci. Znanja i tehnologije koje se razvijaju i primjenjuju kroz uzajamnu suradnju akademske zajednice i industrije naši su zajednički izazovi. MIPRO svojim djelovanjem i ugledom daje snažan impuls tim nastojanjima. Radovi koji se prezentiraju na ovom savjetovanju primjer su visokih standarda u znanstvenom i stručnom radu izuzetnih pojedinaca i sredina. Bez obzira na nužne promjene, sigurni smo da će 43. Međunarodni skup MIPRO 2020 biti izuzetno uspješan i da će imati dugoročne pozitivne odjeke, što nesumnjivo potvrđuje i bogat ovogodišnji program rada usprkos pandemiji. U ime zlatnog sponzora Končara i u svoje osobno ime, Svim sudionicima ovogodišnjeg savjetovanja MIPRO 2020 želim sadržajan i uspješan rad, a organizatorima i kreatorima ovog skupa visoku motivaciju za daljnji razvoj i buduću organizaciju ovako značajnog međunarodnog znanstveno-stručnog skupa. Hvala.
Hvala lijepa gospodinu Bahunu na ovim lijepim riječima. Storm Computers se visokom razinom stručnosti i neprekidnim usvajanjem novih tehnologija, specijalizacija i certifikata pozicionirala kao jedna od vodećih hrvatskih tvrtki u području razvoja, implementacije te održavanja kompleksnih i cjelovitih poslovnih informacijsko-komunikacijskih sustava. Pozivam stoga gospodina Gorana Jovičića, člana uprave Storm Computers, brončanog sponzora i skupnog člana MIPRA, da nam se obrati. Izvolite.
Dame i gospodo, neobično sam sretan i zadovoljan što sam imao priliku doći ovdje i pozdraviti vas uživo. Isto tako pozdravljam i sve MIPRovce koji su se na jednom od kanala Zooma priključili ovom svečanom otvaranju i koji prate sve ovo što se događa u Opatiji. Za razliku od prošlog MIPRA kada nam je padala kiša i onog MIPRA koji je odgođen, nalazimo se danas, kako je rekao gospodin Skala u svom uvodnom govoru, u jednom novom hibridnom vremenu i svi smo nekako resetirani. MIPRO je pravo mjesto i pravi način da svi znanstvenici u suradnji sa gospodarskim subjektima pomognu da zapravo živimo novo normalno koje je nastupilo oko nas. I ovaj hibridni MIPRO je zapravo potvrda toga da to možemo i da nećemo izgubiti ni u jednom segmentu kvalitete i broja radova i znanstvenog doprinosa koji će ovaj skup dati. Mi u Storm grupi isto smo se organizirali i odgovorili na pandemiju. Povećali smo i shvatili da su u uvjetima hibridnog poslovanja online i data centar usluge jako značajne i stoga smo i kao grupa udvostručili kapacitete našeg data centra. Storm kao kompanija oduvijek ili već dugo godina prati MIPRO i to ćemo nastaviti i dalje. U ime Storm grupe i svih naših djelatnika želim vam uspješan MIPRO i hvala.
Hvala lijepa vama što ste nam se uspjeli pridružiti. Infodom grupa obavlja usluge za strategijsko upravljanje i transformaciju poslovanja te usluge za integraciju ICT rješenja. Dugogodišnji je vjerni sponzor skupova MIPRO. U ime tvrtke Infodom grupa obratit će se gospodin Goran Marković, član uprave. Izvolite.
Poštovane dame i gospodo, drage kolegice i kolege, cijenjeni organizatori, svi vi koji sjedite ovdje fizički i svi oni koji se nalazite u cyber prostoru, izuzetna mi je čast i zadovoljstvo što danas mogu ispred tvrtke Infodom i u svoje osobno ime pozdraviti vas i zaželjeti sretan i uspješan rad. Tvrtka Infodom podržava MIPRO još od samog osnutka, što je, rekao bi, nekako nama logično i prirodno, jer Infodom se zalaže od samih svojih početaka za znanje kao temeljnu vrijednost i za suradnju između sveučilišta, gospodarstva i javnog sektora, jer zaista to smo si postavili kao visoki cilj još od samih početaka, jer vjerujemo da zapravo nema prosperiteta i nema pravog napretka ako ne spojimo sva ta tri sektora, što i MIPRO već godinama čini i vjerujemo da će i dalje nastavljati činiti, a sve dok oni to naravno čine, mi ćemo rado podržavati i te skupove. Ono što, tako rekao bi, nerado bih naglasio, ova pandemija i sve ovo što se događa oko nas je na neki način nam i pogodovalo, jer kao što su i moji prethodnici spomenuli, neke stvari su se bitno ubrzale. Dakle, ljudi su preko noći postali svjesni zapravo koliko su važne tehnologije, posebice digitalne tehnologije, da bi uopće mogli funkcionirati. Međutim, želim reći da to s druge strane postavlja jednu novu odgovornost pred sve nas koji smo dugo u tome i koji znamo možda više od prosječnih korisnika i građana, jer to izlaganje cyber prostoru s jedne strane čini ljude i ranjivijim, dakle na neke ugroze koje ranije nisu prepoznali, a s druge strane ta lakoća koju nam nude tehnologije isto tako može zavarati ljude i tako da mogu učiniti zapravo jako puno oportunitetnih troškova, a ne napraviti pravi rezultat. Stoga smo mi i kao tvrtka, dakle Infodom, kao što je rečeno u najavi, zapravo jako puno napora ulažemo u taj konzulting, u osvještavanje što zapravo digitalna transformacija je, kako na najbolji način iskoristiti digitalne tehnologije, a da bi zapravo postigli prave efekte. I zato mislimo da sve ovo skupa je naravno s jedne strane i dobro, jer ljudi su ono što smo mi, o čemu smo razgovarali i na što smo i nagovarali, je pandemija učinila zapravo preko noći da su postali svjesni, ali mislim da nas čeka jako veliki posao i nakon toga da sve to prvo prihvatimo kao novo normalno, a drugo i da postignemo naravno rezultate kako osobne tako i poslovne. Dakle, na kraju bih samo zaželio svima uspješan rad i nadam se da i ovaj primjer kako se može zapravo nastaviti funkcionirati normalno. MIPRO je dakle najbolji primjer i ja želim svima, dakle i kako u virtualnom prostoru, tako i ovdje u fizičkom, da budemo uspješni i da sve odradimo kako spada. Hvala lijepo.
Hvala lijepa svim našim govornicima na njihovim pozdravnim govorima i hvala najljepša na vašoj pozitivi. A sada idemo na nešto također tradicionalno koje će se održati ipak na malo drugačiji način. Profesor Skala već je rekao da ove godine u zborniku radova skupa MIPRO 2020 u elektroničkom obliku objavljujemo 369 prihvaćenih radova autora iz 37 zemalja. Tradicionalno svake godine nagrađujemo poveljama autore 3 najbolja rada na savjetovanjima skupa. Nagrađeni radovi su u zborniku označeni zastavicom kojom maše profesor Baltazar. Pa krenimo sa proglašenjem. Najboljim radom na savjetovanju MIT, mikroelektronika, elektronika i elektronička tehnologija proglašen je Interferometry Measurements of Yeast Cell Suspension and Sediment Process. Autori su Meng Zhang, kao Leuven, Belgium, Tomislav Marković, IMEC, Leuven, Belgium i Bart Nauvelers, kao Leuven, Belgium. Čestitke dobitnicima. Na savjetovanju CTI, telekomunikacije i informacije, najboljim radom proglašen je rad Techno-economic analysis of deployment options for converged 5G wireless optical access networks. Autori su Maurice Bongard, Kai Grunert, Detecon International GmbH, Cologne, Germany i Slaviša Aleksić, Leipzig University of Telecommunications, također Leipzig, Germany. Čestitke i ovim nagrađenim autorima. Treći nagrađeni rad je iz područja specijalnih sekcija i to sekcije OPHO, optoelektronika i fotonika. Naziv rada je Plasmonic Enhanced Photodetectors for Near Infrared Light Detection. Autori su Damiano Giubertoni, Giovanni Paternoster, Fabio Acerbi, Fondazione Bruno Kessler, Trento, Italy. Xavier Borisset, Institut Català de Nanoscienza y Nanotecnología, Bellaterra, Barcelona, Spain. Alessandro Sian, Andrea Filippi, Alberto Gola, Fondazione Bruno Kessler, Trento, Italy. Albert Guerrero Barbero, Francesc Perez Murano, Instituto de Microelectronica de Barcelona, Bellaterra, Barcelona, Spain. Filippo Romanato, Department of Physics and Astronomy, Galileo Galilei, University of Padua, Padua, Italy. Elias Catolo, Pierluigi Belluti, Fondazione Bruno Kessler, Trento, Italy. Čestitke i ovim vrijednim autorima. Jedna od tradicija MIPRO je sekcija studentskih radova MIPRO Junior. Ove godine najboljim studentskim radom proglašen je rad Using Convolutional Neural Network for Chest X-ray Images Classification. Autori su Matija Sorić, Daniela Pongrac, Zagreb University of Applied Sciences, Zagreb, Croatia i Iñaki Inza, University of the Basque Country, Donostia, San Sebastian, Spain. Čestitke. Bravo za MIPRO juniore, ono što svakako moramo reći da su autori najboljih radova kao i svake godine dobili svoje povelje, no ne dodjeljujemo ih ovako na pozornici kao prijašnjih godina, već ih mogu, ukoliko su ovdje u Opatiji, preuzeti na recepciji MIPRA, a ukoliko nisu dakako, bit će im poslani, odnosno uručeni naknadno. A MIPRO, vjerujem da znate, dodjeljuje i još 2 priznanja. Povelju MIPRO i povelju Friend of MIPRO. Tko je dobio ovogodišnja priznanja, reći će nam predsjednik programskog odbora, gospodin Skala. Izvolite.
Hvala lijepo. Poštovani skupe, obraćam se u ime predsjedništva MIPRA. Prosperitet i razvoj udruge uvijek doprinose odani i dugovječni aktivni članovi. Za značajni doprinos u razvoju udruge uručuju se povelje MIPRO. U tom pogledu magistrica Andrea Budin iz Ericsson Nikola Tesla je dugi niz godina sudjelovala u važnim odlukama udruge, poglavito u povezivanju s gospodarstvom, i predsjedništvo MIPRO-a uručuje povelju MIPRO za 2020. godinu. Čestitka. U strateškom razvoju prosperitet normalno je uvijek povezano sa ljudima koji daju nešto više od ostalih i njih ističemo. U strateškom razvoju, proširenju djelatnosti u društveno-humanističkim znanostima i unapređenju savjetovanja Dante, profesor dr. Mladen Maucher u predsjedništvo uručuje povelju MIPRO za 2020. godinu. Čestitke. MIPRO ima mnoštvo sudionika koji često dolaze na godišnju konvenciju. Do sada MIPRO ima 17 istaknutih čestih sudionika iz 10 zemalja koji su proglašeni prijatelji MIPRO-a. Učesnici MIPRO-a koji su bili više od 10 puta na godišnjoj konferenciji i u svojim sudjelovanjem daju dodatan doprinos u aktivnostima i razvoju, dobivaju povelju prijatelj MIPRO-a. Ove godine se proglašava prijateljem MIPRO-a dr. Viktor Avabelj sa instituta Jožef Štefan, Slovenija. Čestitke. U ime predsjedništva i programskog odbora upućujem još jedan put čestitke u nadi daljnje uspješne suradnje. Nagrađeni povelju mogu preuzeti na registracijskom stolu MIPRO-a. Hvala.
Hvala lijepa profesoru Skali i čestitke još jednom. Mi smo u gradu Opatiji u kojem se nalazimo svake godine na MIPRO, kao što smo svi svjesni činjenice da se ovo pomaknulo, svjesni smo i činjenice koliko je Opatija dobar domaćin. I to neprekidno od 1979. godine grad je domaćin skupova MIPRO. MIPRO je postao tehnološki brend Opatije i doveo u nju oko 30.000 ljudi i to ljudi spremnih da svoje znanje prenesu drugima i da prihvate znanja drugih, naravno. MIPRO njeguje dobre odnose s vodstvom ovoga preljepog grada i s njegovim turističkim djelatnicima. U ime grada Opatije pozdravit će nas zamjenik gradonačelnika, gospodin Emil Priskić. Izvolite.
Dobar dan svima, dragi predsjedniče, dragi sudionici ovog međunarodne konferencije. Čast mi vas je pozdraviti u ime grada Opatije i svoje osobno ime. I naravno posebno me veseli što ste ponovo odabrali Opatiju za domaćina vašeg vrijedne međunarodne konferencije. Evo, danas smo malo u nekom drugčijem okruženju ovdje. Inače, Opatija grad koji ima godišnje preko 550 konferencija. Međutim, najhrabriji ostaju, vi ste jedni od tih i znali ste se prilagoditi. Novo normalno, virtualno, hibridno ili kako ćemo već nazvati ovaj vid konferencije, daje i dalje napredak i poticaj ICT okruženju u kojem vi djelujete na način koji sada vidimo. Evo, nadam se da će sljedeći MIPRO koji će se održati ovdje vjerojatno u svibnju sljedeće godine biti u normalnom, bez onog novo normalno, da ćemo u ovoj konferenciji vidjeti 200 ili 300 sudionika uživo, a manje virtualno. S tom zgodom, evo, želim vam još jednom zaželiti dobrodošlicu u Opatiji. Želim da prošetate nakon konferencije Opatijom. Danas sam lijepo osunčana, a vi koji ste u virtualnoj varijanti možete preko naših web kamera ili putem naše panorame 360 upoznati Opatiju i prošetati se i na taj način. Uživajte u Opatiji.
Hvala vam najljepša. Rijeka je grad u kojem je rođen MIPRO, što nije slučajnost, jer Rijeka je kroz svoju dugu i bogatu povijest bila koljevka novih tehnologija. Podrška grada Rijeke MIPRO i njegovim aktivnostima je stalna i višestruka. Ona se posebno ogleda u zajedničkoj aktivnosti u organiziranju tehnoloških skupova Dan novih tehnologija, DANTE, koji se svake godine u studenome održavaju u gradskoj vijećnici u Rijeci. U ime grada Rijeke pozdravit će nas zamjenik gradonačelnika, gospodin Marko Filipović.
Poštovane dame i gospodo, poštovani uzvanici, poštovani predsjedniče, dozvolite mi da sve organizatore i sudionike pozdravim u ime gradonačelnika grada Rijeke, gospodina Vojka Obersnela, naravno u ime grada Rijeke i svoje osobno ime. Kao što je već rečeno, udruga MIPRO nastala je prije nešto više od 40 godina u Rijeci i to nas naravno ispunjava ponosom, ali i obvezom da budemo lider u primjeni novih tehnologija što se tiče lokalne samouprave. To dokazuju i recentna istraživanja savjetničke kuće Apsolon, koja je evo i ove godine grad Rijeku svrstala u lidera u primjeni novih tehnologija i digitalnoj transformaciji među velikim gradovima i naravno da tu jedinice lokalne samouprave ali i država mogu napraviti više i brže i bolje, no ono što radimo na lokalnom nivou daje nam nadu da Rijeka i u budućem razdoblju će se oslanjati na digitalne tehnologije, a to nas je naravno, rekao bih, malo i natjerala ova epidemija COVID-19. Naravno da su veliki izazovi pred naročito urbanim sredinama. Rijeka je najnaseljeniji grad, 2900 stanovnika po kilometru kvadratnom, ne samo u Hrvatskoj nego i u cijeloj jugoistočnoj Europi, pa to onda stvara i dodatne izazove, ali to je onda i najbolji način za primjenu novih tehnologija. Nastavljamo sa cijelim nizom projekata koje smo već započeli. Evo, do 10. listopada traje natječaj za upis nove generacije u startup inkubator, gdje mladi mogu dobiti sva ona potrebna znanja da svoje poslovne ideje pretoče u firme, gospodarske subjekte, zaposle neke nove mlade ljude uz mentorstvo i naravno od prije nekoliko godina i novčane nagrade za one najbolje. Dovršavamo i u zadnjoj fazi je EU projekt proizvodnog parka Torpedo s aditivnim tehnologijama i 3D printingom. U fazi izvedbenog projekta i centar kompetencija za pametne gradove, a isto tako i bivša energana u tvornici papira u Rijeci. No da sad ne opterećujem skup svim projektima na kojima radimo, mogu samo reći da u svim našim strateškim dokumentima digitalna transformacija zauzima jedno od stupova razvoja, a to je tako i na europskom nivou u novom sedmogodišnjem razdoblju. Iako se ovaj MIPRO održava u Opatiji, on se održava i sa pogledom na Rijeku, na ponosnu Europsku prijestolnicu kulture u ovoj 2020. godini, da ja pozivam sve one koji su ovdje fizički sa nama da posjete Rijeku i neke od izložbi koje su upravo otvorene ili će biti otvorene ovih dana. I još jednom želim svim organizatorima i sudionicima uspješan MIPRO i vidimo se dogodine u, nadam se, nešto izmijenjenim okolnostima.
Hvala vam lijepa. Ministarstvo mora, prometa i infrastrukture godinama je pokrovitelj i suorganizator skupova MIPRO, osiguravajući MIPRO poziciju partnera po pitanjima informacijskih i komunikacijskih tehnologija, posebno u području zakonske regulative. U ime ministarstva pozdravit će nas načelnik sektora elektroničkih komunikacija i pošte, gospodin Krešo Antonović, koji nam je već, sigurna sam, na liniji. Dobar vam dan. Pogledamo, mislim da ga čujemo. Ukoliko je na Zoomu, jel pobjegao, onda ćemo probati još jednom. Upravo je nestao. Pa nema veze, to tako i ide, na to smo već navikli. Kako ste vi, ljudi? Je vam lijepo pod maskama, jesmo se navikli već svi? Meni su rekli kao što se mi sad žalimo, kirurzi operiraju po preko 12 sati na najtežim operacijama, pa zašto bismo se mi sad žalili na par minuta ili na jednom ovako svečanom otvorenju pod maskom. Pa ako se možemo zaštititi i sebe i druge na taj način, to je to. Jesmo li se uspjeli spojiti? Nismo, nažalost, no evo, samo da se primi na znanje, danas je i gospodin Antonović htio pozdraviti u ime ministarstva. Hvala najljepše ministarstvu na potpori kroz sve ove godine. A je, evo ga. Ima lošu vezu. Onda ništa. Onda hvala. Evo, sve sam bila već rekla pa da se ne ponavljam. Ono što nam je zbilja bilo bitno i velika nam je čast i zadovoljstvo jest što je i predsjednik Republike Hrvatske, gospodin Zoran Milanović, prepoznao važnost skupa MIPRO. Nažalost, nije mogao osobno doći na današnje otvorenje, ali je za svog izaslanika imenovao gospodina Sašu Drezgića sa Ekonomskog fakulteta sveučilišta u Rijeci. Stoga pozivam gospodina Sašu Drezgića da vas pozdravi i otvori MIPRO 2020. najveći nekomercijalni tehnološki ICT skup u regiji. Izvolite.
Hvala. Poštovani predsjedniče Hrvatske udruge MIPRO, profesore Mornar, uvaženi gosti, dame i gospodo, zbog nemogućnosti sudjelovanja na otvorenju 43. međunarodnog skupa MIPRO 2020. godine, dopustite mi da kao izaslanik predsjednika Republike Hrvatske Zorana Milanovića ovim putem u predsjednikovo ime i u svoje osobno pozdravim organizatore, sudionike i sve uzvanike skupa koji se ove godine održava tradicionalno u Opatiji, ali i u virtualnom svijetu. Skup posvećen usmjeravanju i nadgradnji tehnologije i društva prilika da se skrene pozornost i pošalje poruka o važnosti uloge tehnologije u oblikovanju naših života. I prije ove pandemije bolesti COVID-19 bili smo svjedoci stalnim ulaganjima u tehnološki razvoj u svrhu poticanja gospodarskog razvoja i društvenog napretka. Danas, kad svjedočimo ponegdje iz temelja promijenjenom načinu poslovanja, rada ili obrazovanja, tehnologija sudjeluje i u prevladavanju raznih izazova i problema i omogućava nam manje više uredan život u novoj normalnosti. Upravo zbog toliko velikog upliva tehnologije u sve pore naših života, dobro je da se održavaju ovakvi skupovi koji uz sudjelovanje eminentnih domaćih i inozemnih stručnjaka, kao i predstavnika relevantnih institucija, mogu pridonijeti stvaranju novih poticajnih i razvojnih mogućnosti. Jedna od takvih mogućnosti vezana je uz središnju temu vašeg skupa, robotika, budućnost tehnološkog svijeta, čija su postignuća upregnuta prije svega u funkciji industrijskog i gospodarskog napretka, a čiji trag nalazimo i u drugim životnim sferama, primjerice u funkciji rasta kvalitete zdravlja i obrazovanja. Robotika kao i digitalizacija, koja nota bene uz zelenu tranziciju čini osnovu pokretanja europskog gospodarstva i osiguravanja europskog oporavka u narednom 7-godišnjem razdoblju, predstavljaju Hrvatskoj priliku za nov, ubrzan ekonomski rast. Mnoge naše tvrtke i pojedini sektori gospodarstva mogli bi se razvijati snažnije i brže, a našu ekonomiju mogli bismo učiniti mnogo atraktivnijom i konkurentnijom. Za razliku od mnogih srednjoevropskih država u kojima se dogodio investicijski val od 2000. godine do ovamo, Hrvatska ima mogućnost prihvatiti investicije sada, kad je tehnologija drugačija, naprednija, kada radna mjesta imaju veću dodanu vrijednost i kada su investitori dio nove globalne promjene. Vidimo to već na primjerima naših tehnoloških perjanica, Nanobita, Infobita, Infiniuma i tvrtke Rimac automobili. No, da bismo prednosti digitalne transformacije mogli koristiti, a budući strateški razvoj Hrvatske uistinu mogli temeljiti na novim tehnologijama i infrastrukturama informacijske i komunikacijske tehnologije, osim infrastrukture i povoljne poslovne klime, moramo imati obrazovanje primjereno zahtjevima 21. stoljeća i potrebama ne postojećih već budućih tvrtki. U tom pogledu, predsjednik Republike iskazuje potporu jačanju suradnje akademske zajednice gospodarstva i napose pozdravlja rad i djelovanje Hrvatske udruge za informacijsku i komunikacijsku tehnologiju, elektroniku i mikroelektroniku MIPRO, čiji je jedan od temeljnih ciljeva i zadataka upravo stvaranje i prijenos znanja i tehnologija. Čestitajući organizatorima na uspješnoj organizaciji skupa, u uvjerenju kako će okupljeni vodeći stručnjaci iz područja ICT-a i gospodarstva svojim stručnim znanjem i međunarodnim iskustvom pridonijeti daljnjem razvoju tehnologija na dobrobit gospodarskog i sveokupnog društvenog napretka, u ime predsjednika Republike srdačno vas pozdravljam i želim puno uspjeha u radu cijenjenog skupa.
Hvala lijepa gospodinu Drezgiću, izaslaniku predsjednika Republike Hrvatske, i pozdravimo još jednom sve naše uvažene govornike koji su nam se danas ovdje i fizički pridružili u Opatiji. Hvala vam najljepše što ste došli i što ste okupljenima uputili pozdravne govore. Možete sada slobodno otići u publiku i udobno se smjestiti i uživati u nastavku programa. A kao svojevrsni intermezzo ovog svečanog otvaranja opet ćemo čuti jednu divnu skladbu naših gostiju umjetnika. Već sam ih bila predstavila, naš doista umjetnik na gitari, gospodin Mario Šimunović, i divna i talentirana Martina Majerle. Izvešće nam dakle još jednu krasnu skladbu. Čisto da se malo odmorimo i predahnemo, a potom prelazimo i na radni dio svečanog otvorenja. Uživajte.
Tengo la camisa negra porque amor está de luto. Yo tengo el alma una pena y es por culpa de tu embrujo. Yo sé que tú ya no me quieres y eso es lo que más me hiere. Que tengo la camisa negra y una pena que me duele. Mal parece que solo me quedé y fue pura todita tu mentira. Que maldita mala suerte la mía que aquel día te encontré por beber del veneno maleo de tu amor. Yo quedé moribundo y lleno de dolor. Respiré ese humo amargo de tu adiós. Desde que tú te fuiste solo tengo la camisa negra, porque negra tengo el alma. Yo por ti perdí la calma y casi pierdo hasta mi cama. Come on, come on, come on, baby. Te digo con disimulo que tengo la camisa negra y debajo tengo el difunto. ¡Ey! Tengo la camisa negra porque amor no me interesa. Yo por ti me supo a gloria, hoy me sabe pura. Miércoles por la tarde, tú que no llegas, ni siquiera muestras señas. Que tengo la camisa negra y tus maletas en la puerta. Mal parece que solo me quedé y fue pura todita tu mentira. Que maldita mala suerte la mía que aquel día te encontré por beber del veneno malevo de tu amor. Yo quedé moribundo y lleno de dolor. Respiré de ese humo amargo de tu adiós. Desde que tú te fuiste solo tengo la camisa negra. Por amor no tengo el alma. Yo por ti perdí la calma y casi pierdo hasta mi cama. come on, baby. Te digo con disimulo que tengo la camisa negra y debajo tengo el difunto. ¡Ej! Hvala najljepša. Hvala.
I Mario, dame i gospodo. A sada kada su sve nagrade podijeljene, kada je ovogodišnji MIPRO i svečano otvoren, vrijeme je dakle da prijeđemo na onaj radni dio. No, do tada imamo nekih 5 minuta, čisto da se malo opustimo, pripremimo ako imamo neku bilježnicu za pisanje bilješki, obavimo što trebamo i onda se spajamo i prvo idemo u Njemačku. Dakle, za 5 minuta kreće plenarni dio.
Predstavlja najbolje što nam Hrvatska pruža. Ulaganjima u energiju sunca, vjetra i vode. Više od 50% energije koju proizvodimo dolazi iz obnovljivih izvora. HEP transformira budućnost u sadašnjost kako bismo sačuvali sigurnost naših domova i povjerenje budućih generacija. Energija koja pokreće Hrvatsku. HEP, više od struje.
2020. Poštovanje, hvala vam lijepa na strpljenju. Evo, dakle, vjerujem da neki od vas koji su bili ovdje i prijašnjih godina znaju da je prije par godina uveden radni dio ovog svečanog otvaranja, stoga ćemo ove godine imati 2 plenarna istaknuta predavanja. Kao i inače kada su predavanja ovdje in vivo na pozornici sa predavačima koji su u Opatiji, nakon predavanja možete postaviti pitanje. Također to vrijedi i za sve ljude koji nas prate online, dakle u chatu, na Zoomu, slobodno postavite pitanje ukoliko želite tijekom i nakon predavanja naš će predavač odgovarati na iste. So for everybody who is watching us online, if you would like to ask any question, you can freely ask it in the chat section of your Zoom channel, or if you're here and you want to do the same, you can just raise your hands when the lecture finishes and the microphone will come to you. Dakle, prvo predavanje zove se Future of Robotics, From Challenges to Innovation, a prezentirat će gospodin kojeg ste malo čas mogli vidjeti na velikom ekranu, Rainer Bischoff. Hello, nice to have you here with us virtually. The floor is yours.
Thank you. Thank you very much. Good morning, everybody. I'd like to say thank you to the organizers for inviting me to give this keynote at the opening of MIPRO 2020. I hope you can all hear me well. I'm sorry that I cannot be with you today. I am here in Augsburg, Germany. It's the headquarters of KUKA, and I give all my greetings to you in Croatia. What I would like to talk about is the future of robotics, at least how a robot manufacturer like KUKA sees it, how we address our customer challenges, and how we are able to make innovative products and solutions. Where do all these challenges stem from? Of course, you know about the societal challenges that we have. It's mobility challenges, it's the ever-changing challenges of globalization. Global warming is a big challenge. The overaging society, urbanization, how the young ones, the digital natives are connecting, it's individualization, everybody wants to have individualized products, and of course it's about health. And all these societal challenges can be helped with robot systems. So this is something that we are looking into at KUKA, but also we look into what our customers want and what the market situation is. And if you look at this figure from IFR, the International Federation of Robotics, you can see that there is 2 huge gaps to be seen. One gap is there between, in a Western country like Japan, between 1,200 robots per 10,000 employees in the automotive industry, and about 200 robots in the non-automotive, in the so-called general industry. So this is a huge gap which can still be filled, and there's therefore a huge demand for robotics. And the second gap that you can see on this slide is from the emerging markets. So if you look at China, Brazil, or India, they have very little robots so far per 10,000 employees. So there's still a huge gap here, which also demands for robot technology. Also, these countries have to improve on their quality and to reduce their cost. So there's currently a big boom in robotics, and all the big robot manufacturers and the small ones, of course, are benefiting from this trend. So if we look into our customer challenges, this is something that we have to do early onwards. If you just think about how KUKA is developing its roadmap, if we want to sell products by 2025, actually, we have thought about this 10 years ago. So that means starting 2015. Because we always have these three-stage phases from technology development over pre-development to product development before it can really become a product on the market. So we have to think ahead what might be future customer challenges. And of course, this relates to societal challenges, but also very much to what the customer wants. KUKA has always been a very customer-driven company. And to give this a more technical spin, how we are organized and how do we create sustainable solutions and how do we convert research into commercial success. If we look at this figure, this depicts the technology readiness levels on the left-hand side. And research outside KUKA is usually happening between TRL 1 and TRL 3 and sometimes reaching also into 4 and 5. My team at KUKA, I'm heading corporate research, is doing the technology development across the KUKA group. And then product development is taking place between TRL levels 7 and 9. This is where the products, the applications, and the solutions are being made. And there's just one number between 6 and 7, but usually this is referred to as the valley of death. So this is where all the good ideas somehow fall into this valley of death and do not make it to products. And at KUKA, we have a special team and special projects created to overcome that valley of death, which is then staffed from people of my team and people of the series development teams to create so-called advanced product development projects, where we temporarily exchange developers and then further mature the technology that come out of my lab. And where do we get all the ideas from? Of course, this is not only inbreed into KUKA, but we are looking very much into research outside KUKA. And we have a lot of collaborative research projects funded by local governments, by the region and by the European Commission, so that we can actually have a good network into the robotics community in Europe. And based on what are we doing in these research projects and what we are doing towards productization, this can be very well depicted with the 4 robotic revolutions, how I try to coin this. These are 4 robotic revolutions, not to be mistaken with the 4 industrial revolutions. So in these 4 robotic revolutions, this is what we are all aware of. The first robotic revolution, this is simply when it all started to get robots helping to manufacture goods, so robot-based automation solutions. Since 2010, approximately, we are witnessing the second robotic revolution, which is that the robots are not any longer behind fences, but they are becoming more sensitive and safe so that they can work without fences. In the third robotic revolution, we add mobility to such robots. And in the fourth robotic evolution, even comes with cognition. I will go into more details in all these 4 robotic revolution steps in my next slides, so that you can have a better understanding. But maybe to summarize the first 3 steps under one umbrella, and this is that these 3 steps can still be manually programmed. This is still automatic robots, while at the 4th step, we see more autonomy in the robot technology. So automatic versus autonomous, this is again a huge gap, which still has lots of research in it to get realized. But coming to the first robotic revolution, robot-based automation solution, you're probably all aware of this. So to the left-hand side, you see use cases in metal arc resistance welding, gluing and sealing. Here an example of a BMW manufacturing. You see our big industrial robots all behind fences. They're all stiff, dumb and numb, blind, and they need fixtures of the parts to be able to get a high precision into the production. So here you see how a robot is doing spot welding. So this is very classical processes, and 99 of the body in white production of today's cars is automated like this. There's another good technology which is called robot-robot cooperation. And here you have use cases in process optimization and material flow, where, for instance, 2 robots are holding one workpiece, or one robot is holding a workpiece and another robot is performing a dedicated operation on this, as you can see here in the picture. And to the right-hand side, another key technology used in these kind of things is sensor integration. What you see here is a robot used for seat testing. And this robot has a force torque sensor at its flange and is imitating or emulating the entry and exit and the typical motions of a human body on a car seat, and thereby testing the car seat. So these are all typical robot applications and technologies for the first robotic revolution. In the second robotic revolution, we add the term sensitivity and safety. And I would say a very good incarnation of the second robotic revolution is the KUKA lightweight robot. It has very unique features, such as gravity compensation. Gravity compensation can be used to use torque sensing and good models of the robot to only have very little forces needed to push the robot through its workspace, for instance, for hand guiding and for teaching operations. The second feature of the robot is that it has 7 degrees of freedom and not only 6, like most standard robots. So it means it has an elbow, very much like a human arm, and therefore can be employed like human arms in, for instance, in assembly tasks. And the third feature, which is important, is a programmable compliance, which means that I can make the arm more stiffer or more compliant depending on the task at hand. And this is very interesting, these three features to be combined on the shop floor today. And what is needed then on top of that to make it really applicable and that such robots are able to work behind fences is safety. So we have diverse measures in the robot, inside the robot arm, like redundant encoders that enable us to detect forces that are not expected and then to stop the robot, but also to exert forces like the inserting of a gear into a box if the forces are needed. So here again, you see the very difficult situation of clamping, which is prevented by the robot system. And to give you a glimpse on the use case, this is the fastening of a pump pot of a dishwasher with screws. It's one of our many feasibility studies that we have done here with Bosch Siemens Hausgeräte. You see how the robot is on a mobile push cart. It is being fixed to the location, but then still the robot has to calibrate and register itself with respect to the work object and to the production line. This is done in the first step. And then the task of this robot is to fasten a pump pot. So this is a plastic part in the middle, a plastic part here in the middle of the housing of the dishwasher. It has actually 4 screw holes, and the robot has to fasten these screws. And since this is a plastic part, it's never really lying 100% at the same location, so that the screws have to be actually searched for. And with the sensitivity of the robot, you can use it to find the screw hole and then to insert the screws. The process cycle time that was given to us was 16 seconds. In the end, we were able to realize 14 seconds. And only if the robot had to search intensively for the hole, this was then extended. What is also necessary to look at is the whole automation chain of these kind of automation problems. And this is, for instance, the feeding of the parts that you need in this case, and these are screws. And another important topic is, of course, if there's a problem, a human always has to come in, stop the robot by touching it, and push it again just to restart the procedure. So this is where human-robot collaboration really makes sense at the production line. Another example for safety around humans is needed, for instance, in the medical field. Here you see a KUKA robot integrated by Siemens to a medical device, which is used to take 3D images of patients in the operating room. And of course, this robot is operating, it's rotating around its tool center point, taking images, and you see 3 surgeons or medical staff standing around the person itself. So no fences are possible, but this is very, very good technology to help humans with their procedures. Coming to the third robotic revolution, this is when we now add mobility to the otherwise stationary arms, and it's getting more complex here. So you see this already from the design of our many robots, from very small robots for education and research to very large robots with several tons of payload. But they all have the same principle. They have these mecanum wheels, which allows the robot platforms to move omnidirectionally. And here you see 2 examples. One example from Hanover Fair, where this robot actually has won a prize. And this is a large robot which is able to work on large work pieces. So a single robot arm would not be able to polish the whole windmill structure. But if you have a mobile base underneath the robot arm, you are able to polish the whole structure. The navigation is done based on laser scanners, based on maps. This is today technology which is commonplace. But if you further want to look into the future, to the right lower left, you see a picture of Mercedes-Benz, Daimler, Bosch, Stuttgart University in the Arena 2036 project. This is how they envision car production in only 16 years from now. So you have lots of mobile manipulators running around the shop floor, collaborating with humans, and you have many different cars going along the same production line, all manufactured by robots. Of course, this is a vision. Then you do not only combine the advantages, but you also harvest some of the disadvantages which result in technical challenges. And the first one is, of course, precision. If you add a mobile base to a stationary robot arm, you get uncertainties, the inaccuracy of the platform. So you will never be at the same location where you have probably taught a special task. Safety becomes a much higher problem even than just with stationary arms, because you add a mobile platform which cannot be behind fences. You have uncertainty in the environment. The environment is constantly changing because humans are also in that environment, which requires navigation, planning, environmental models. System complexity is rising significantly because you add some degrees of redundancy. You need other control methodologies for true mobile manipulation, that you can manipulate objects while you are moving with the platform. And you have to think about how you can actually operate such systems. How do you program them? Modularity becomes an issue also for maintenance and repair and for scalability. System integration becomes a much bigger problem in terms of software architecture, sensor technology. System pricing, of course, is a topic. No one is paying for a feature that is not needed. So you really, if you have a mobile manipulator, you have to make use of the mobile platform and of the robot arm, and performance as such becomes an issue. You will also see this in the following video. This is the result from a research project that we have been doing together with Grundfos in Denmark. Grundfos is the largest pump manufacturer in the world. And here you see a few parts of these pumps, which are being moved on the shop floor from A to B, from where they are produced to other places where they need further production steps. And in this particular case, we have a mobile platform with a robot arm. This platform is then having also two stereo vision systems on pen tilt unit. And with these two stereo vision systems, the robot is actually modeling its environment. And at each location, this model is updated and the robot is planning its path in this three-dimensional environment. And only by doing this regular updates, the robot is really able to perform the intended tasks. You can also, here you see, manipulate other equipment mechanically. Navigation is done with the two laser scanners, the two yellow items you see at the bottom of the robots. Navigation as such, I mentioned it already, is, I would say, a solved problem on the shop floor. Despite this environment, which is not specifically prepared, navigation is something that can be reliably done. What will always remain a challenge is that once you have arrived at the workstation where you have to perform your task, you will never be there at the same location. So you have to register yourself again with respect to your environment, and you have to use vision systems or other sensing systems to get an environmental model. And what you see here in this particular sequence of the video is that the robot is planning and replanning its path time and again to perform this operation. Also because the workspace is kind of limited, and workspace limitation mean limited in the workspace of the robot, not in the workspace of what we as humans normally think of as workspaces. So this becomes clear if you look at this video now. This is a small load carrier which has to be put on the platform of the robot, and it's a rather complex path that the robot has to take in order to put the box on the platform. This is the shortest path in terms of automatic path planning, given the environmental models for the robot, because the robot is performing this path planning in joint space and not in Cartesian space. And it results also in rather funny motions, which are not predictable by humans, which again poses a problem of safety if humans are around. And this is something that we still have to take care of in our developments. Another problem that you have probably noticed by looking at this video is the speed of operation. So this robot is actually, or the video has been accelerated by a factor of 8. And only with this acceleration by a factor of 8, somehow we like to look at this video and think, okay, this is kind of good performance. But it's also a huge challenge to increase the speed of the actual robots to get human-like performance. And this is also one of the challenges that we are still facing. So not to have slow robots and accelerate the videos, but accelerate the robots and show videos in real time. Okay, coming to the fourth robotic revolution, as already said, this is where we add cognition to the whole topic. And cognition, as a definition, is the mental action or process of acquiring knowledge and understanding through thought, experience, and the senses from the Oxford Dictionary. So this applies to humans. If you want to speak in artificial intelligence terms, so for machines, it's called AI. And here's a picture of EU robotics. It's the European Robotics Association. I will come later to this a bit more in detail. This is how we see how robotics and AI overlap. There's a big part of overlapping here. This is called physical AI. And I would like to give you one example here. So if you just think in terms of AI, maybe a good example is of a chess playing program. So there's lots of chess computers out there that are able to beat a human world champion in chess playing. But if you look into a 6-year-old child that is able to get a box from a shelf, open this box, take out the chess figures, set up the chess figures to play chess, and then starts playing chess, this is the kind of physical AI, I mean, which is so important nowadays. So you have to combine artificial intelligence with the robots, and only then you will be able to manipulate things in the physical world. So not only play chess on a theoretical level with a computer, but have a robot that is able to perform physical manipulation in the real world. So to move based on some intelligence, or you can also call this cognitive mechatronics. This is, to the right-hand side now, a picture how the European Commission is seeing it. So this is more a political view, and we simply have to adapt if we want to get still funding from the European Commission. So here, robotics and big data, IoT, cybersecurity, this is all part of a big AI bubble, and robotics is also part of that. But in a technical view, I'd rather like to refer to the left-hand picture that you see here. And then there's still maybe some confusion between symbolic and numeric AI. Definitely robots need both in the future to take intelligent decisions, because they have to take decisions on experience and or knowledge. And experience is gained by learning. And here deep learning is one subcategory of machine learning, which is subcategory of numeric AI. And the knowledge is something that has to be represented for the robot, and then you can reason on that knowledge. And this is the whole area of symbolic AI. So both are needed to make robots more intelligent and autonomous. And where robotics actually meets AI is depicted here on this slide. Starting here on the top, you know, all the vision technology, Google, Microsoft, Amazon, they all have vision technology that is able now in 2D images to detect everyday objects. But for the industry, it's still a big challenge to detect objects. But this is also a field where AI can help. Then grasping, I will come to this in a second slide just now, how to learning how to grasp objects. Then you can also use it to learn how to move, for instance, for pack and hold operations, which are not taught beforehand. You can use AI and big data, especially to use this for predictive maintenance. That means that you can know in advance when something might fail and look into the data and then do the maintenance as needed. You can also use this to do some quality assurance. This here is a picture of a robot that is putting terminals onto a headrail, and just by the clicking sound, but also by the click that the robot is feeling in this internal torque sensing, you can have an idea whether the insertion of the terminal on the headrail was successful or not. And you can make use of it for process control, for instance, to teach the robot to sort objects into the left and into the right bin, just based on the colors, height, and shape of the objects. A very simple process to teach robots to do this sorting. But I would like to give one more example in more detail, and this is to have a robot learning how to grasp, because this is very interesting. We have here a 3D camera next to the gripper, and the robot is learning to grasp objects like a baby, so like an infant trying to reach for objects for the first time. So in the beginning of the process, the robot is maybe able only to grasp 1% or 2% of the object just by chance. But if you let the robot continue with this grasping attempts and have this reinforcement learning methodology, this robot has learned in 35 hours with 12,500 grasp attempts how to grasp objects. These are wooden objects, wooden cylinders and wooden cubes, and it's also sorting them to the left and to the right, depending on the opening width of the gripper. This is a depth image this is taken. So no one has ever programmed any vision. Here in this example, the robot has simply taught itself how to do it. So this is really amazing technology. And what is even more amazing in the end is that although you have learned this with these wooden objects, somehow the robot is able to generalize over these object categories. So the robot is also able to grasp objects that it has not seen before. But they have somehow the robot has understood what it means to grasp objects from this bin, and is doing this also for different objects. And to give you an example of one of our funded projects in this area, this is called Hybrid and Intelligent Human-Robot Collaboration. Here, humans and robots have to collaborate on the shop floor in hybrid teams. Here, for instance, in Airbus aircraft assembly, or here in the final assembly of an automotive manufacturer, in this case, Volkswagen. And you can see in both pictures here, the motivation why we need also robots in the final assembly, which is today not the case. Because the situations where the humans are operating are very unergonomic. So you have very often you have to carry heavy objects and you have to work overhead, which you can probably only do 10 years on the production line before you are getting shoulder problems. Here's the second example. Working overhead is not such an ergonomic thing. And to work on these kind of topics, we have been developing a basic technology, dual arm mobile robot systems that are able to carry out separate end-effector tasks where the redundancy is solved automatically, and also developing technology which is important for the final assembly line, that a robot like this is able to drive onto a belt, to move with the workers and the cars on the belt, performing the operation, getting off the belt and moving back to the front again. So very similar to what the human workers are doing. What is still a problem and a long way to go, of course, is the communication between the humans and the worker. This is still something which is not yet happening. And finally, industrial technology meets operational technology. Digitization is helping in all these 4 revolutionary steps to increase the productivity, to increase customer benefits. And that's why I put this here as a bar across all 4 robotic revolutions. And KUKA has, of course, to also serve this trend of digitization. And it's a kind of revolution which is taking place also inside KUKA. We are coming from a machine tool or from a machine manufacturer only building robots and also building, of course, production lines of many hundreds of robots. But now we have to become really a process company, and we have to become a company where the processes and the technologies are available through the cloud, where all robots are connected. And at least we have to offer also for our small customers, not for the big OEMs, they have their own cloud technology. But we have to develop our own cloud technology for the customers who do not have so many robots, but still want to benefit from the digitization. Yes, so this brings me to a first conclusion. What you have seen here through the 4 robotic revolutionary steps is how we somehow shift from today's way of programming and operating robots to a future with robot assistance. So today, very commonplace is offline programming. You have to teach trajectories. You use fixtures and you have fixed grasps and fixed grippers to do this, and maybe 2D cameras and force torque sensors. But that's about it. In the future, we will have safe cognitive manufacturing assistants which come along in various forms. One of the forms you can see here, again, a mobile platform helping in a section of an aircraft assembly. You will have whole body motion control because you have a mobile platform and you have an arm on top of it and maybe 2 additional degrees of freedom as here in this column. Then from point and line programming, you will come to task descriptions where you automatically derive the motion and the grasp planning. You have 3D object detection, not only 2D, semantic environmental models so that humans and workers, that robots and human workers can easily communicate. And you will also see more industrial object databases and not only general day objects. This, of course, cannot be done alone, not by a single robot manufacturer. So the whole community has to work together. And KUKA has been very strong in so-called cooperating in funded research projects with a huge network of partners. And across these 4 robotic revolutions, we have been doing so. So each of these icons is standing for one funded project of 3 to 4 year duration with 7 to 14 partners. And it's really necessary to cooperate across the whole ecosystem to be able to come up with such technology. And of course, in recent years, we have been focusing on the 3rd and on the 4th robotic revolution with our technology development plus the industry 4.0 topics. A good start to collaborate with KUKA is to apply for the KUKA Innovation Award. This has been going on now since 2014. In November, we will have the final for the Medical Robotics Challenge. 5 teams will have really interesting topics to show. Unfortunately, at a virtual Medica. Already last year, we have been in Düsseldorf at Medica with the healthy living topic. Also a very good competition, so I can only urge you to look into this, also especially in the final mid of November. And next year, we have a challenge called Artificial Intelligence. Here also the 5 finalist teams have already been selected, and I hope this will be a good final at Hanover Fair next year. For 22, please have a look at our announcements and apply to work with us here on very nice innovative topics. And another way to collaborate and start is to look into what is happening on European level. So I would also like to ask you to become a member of EU Robotics AISBL, which is the representation and voice of robotics in Europe in Brussels. We have more than 250 members, and it's really the starting point of successful collaboration between industry and academia. And you see here from the figures how the membership is being set up. So about 1/3 industry members and about 2/3 academic members. And yesterday night, I just checked how well robotics from Eastern Europe is represented. And you see here a big hole, a big gap. So I would also like to ask you, because I'm somehow hoping that many of Eastern Europe are attending this conference, please apply for EU Robotics membership to get your voice heard in Brussels. And there's only Zagreb University here from Croatia, a member. I think this can be very much improved. Yes, this brings me to the end of my presentation. If you have questions, I'm happy to answer them. Otherwise, thank you very much for your attention.
Herr Bischof, I think we do have a question here in Opatija for you. Professor Scala, the microphone is yours.
Yeah. Dr. Ryder, it was very nice. Thank you very much for this very deep and extensive overview.
Any questions?
Overview of
I don't hear anything at the moment. So if someone's talking to me, I'm sorry to say I cannot understand you.
Can you hear me now? Professor Bischof? Can you hear me now?
Hi. Hi, Dr.
So I still cannot hear anybody. So if there should be any questions, maybe you can also type them into the chat window.
Dr. Bischof, are you hearing me?
Ok, ako ćemo uspjeti.
So if you can still hear me, I don't hear anything. I'm sorry. Now it's okay.
Oh, finally. Thank you.
Now it's okay. I'm hearing you. Yes.
Okay, so
Sorry.
we have a question for you from Professor Scala.
Yes.
Hi, Rainer.
Yes, hello.
Hello, hi. Thank you very much for this very nice, deep and extensive overview of robotics. I want to ask you one question. What is the follow-up development and application field in KUKA after automotive industry? And how you want to use artificial intelligence in this new field of area of development?
Yeah, so one interesting area for KUKA outside automotive is, of course, medical robotics. I've been showing a very short video about medical robotics, but this is a growing demand also to get higher precision and to get better therapy for patients around the world. And this is where robots can definitely help. So you can use them for diagnosis and for therapy. And we have the lightweight robot arm that you saw as an industrial version is also available as a medical version. And you can see also big robot arms, as I showed in the video before, for treating tumors, for instance, for treating cancer. And the two last recent Innovation Award challenges, they were all dealing with medical robotics. So this is a hugely innovative field where robotics can still significantly contribute to the well-being and to the health of all citizens. And this is an area which I particularly like very much. And it's also, by the way, one of the 4 areas that Europe is favoring. If you want to say that Europe has a special know-how in robotics, it's turning towards 4 major application fields. One is healthcare, the second one is agri-food, the third one is maintenance and inspection of large infrastructures, and the fourth one is manufacturing, of course. So these are the 4 strongholds of European robotics or application areas where robotics is currently being applied. In medical robots, mostly artificial intelligence is being used to diagnose. So you can take high precision pictures with the help of robots, but then you still have to do the diagnosis. And of course, artificial intelligence is helping here, as in many other fields, when it comes to big data and to analyze what's going on, where the human eye cannot really see differences. Artificial intelligence algorithms are still able to see differences and maybe to differentiate between good and bad tissue. Thank you. Thank you for the invitation. I hope to see you one day all in real life. Yes, so I'm not so much looking into the social pressure that could come from robots all around the world, but if you look more deeply into this, there's also a demand from, let's say, from the Chinese population not to do these dull and dumb and dangerous jobs anymore. So they have the same feelings and the same health that we have. So there's also a big problem of rising wages in China. So China will only be able to keep the productivity up and to still remain the productivity powerhouse or production powerhouse of the world if they also automate more and more. And what I was showing with this particular slide is that there's a huge demand of robotics all around the world. With the consequences in society, if we start automating more and more things, this is something that humanity, I would say in the past, has always been able to deal with. We are not talking about that robots are taking over the world, because they are still in their infancy. If you look at the Tapas video again, where we helped the pump manufacturer Grundfos, this is far from something being applied at any productivity level, because we are far from being able to reach human-like performance, neither in motorics nor in sensing technology. I can hear you. I can hear you.
Hello, Mr. Rodrigo.
Hello.
Thanks for your excellent presentation.
Thank you.
I am a student from University of Zagreb, working in Slovenia, and I know very well KUKA. I have one question. You speak about robot density in industry.
Mm-hmm.
Have you information about robot density only for automotive industry?
Yes, so the gray column in my presentation, this was only for automotive industry, and the blue column, the much smaller one, was for general industry, so non-automotive. And you could see from that non-automotive column that it was much smaller, also in the Western world, not only in the emerging countries. So there's still a huge potential, both in terms of emerging countries, but also in terms of that standard manufacturing has to catch up with what automotive is doing. Automotive is very innovative in applying robotic technology, and other manufacturing fields can benefit from what automotive is doing.
If you know that Slovenia is in third place in world for density in automotive industry. But I come from automotive industry.
Yes.
We have a Renault factory.
Yes, but I'm sure that in the body in white, you also have many robots applied in that factory. And not so much in the final assembly. So these are things where we have to work on to also relieve human workers from bad ergonomic situations, and that they, I mean, the workers in the automotive production lines are getting older. And at Volkswagen, for instance, they're getting older 1 year every year. So the average age of the workers, and not so many people are willing to work in these factories anymore because of these health problems. And this has to be addressed.
Only one provocative question. Where is KUKA in COVID-19?
Well, at the moment, COVID is over for KUKA at our own headquarters. So if we have safe workplaces, we have to come back to work at 100%. And at the moment, I would say maybe 60 or 70% of our workforce has safe workplaces. And safe workplaces is defined as having at least 1.5 meter distance at the workplace. And if you run around between the workplaces, you have to wear a mask. And so about 70% of our workforce is returning already to the workplace, and the others are working from home.
Okay, Rainer, thank you once again in front of Organizing Committee for your contribution.
Thank you very much again for the invitation.
Thank you. Have a nice day.
Thank you.
Bye-bye.
Bye.
Take care. Evo, dame i gospodo, prvo plenarno predavanje je gotovo, zahvaljujući tehnologiji i činjenici da smo ove godine hibridni. Bili smo u Njemačkoj, a zbog drugog predavanja s našim kamerama selimo se u Francusku. Na redu je predavanje na temu Combining Human and Robotic Motion Control for Medical Devices, koju će nam prezentirati gospodin Guillaume Morel. Hello, good afternoon.
Hello, can you hear me?
Yes, we can hear you. Hello and welcome by link to Opatija, and thank you for being with us today.
Okay, good morning, everybody.
Hello, the floor is yours.
Okay, you can see the slides as well.
Yes.
Okay, perfect. Okay, Well, my name is Guillaume Morel. I'm a professor here in Paris at Sorbonne University, and I'm very honored and very pleased to give that talk today, which will make a final or a complement to Rainer Bishop's talk that was more on industry, and where we talk more about medical devices. I would like to thank the organizing committee for inviting me to give that plenary talk. And we will start now. Again, the ideas that will be developed here are very complementary and in the same way of what Rainer has shown, and because they concern the collaborative control between human and robots, and the way we more particularly do the combination of the two actions in one single task. And this will be focused on applications of medical devices. By collaborative robots, here we are talking about collaboration with a user that is in the loop, in the real-time loop of the control of the medical device. So we have different scenarios. The oldest one is called. Oh, I guess I have a real problem with my presentation, but that's okay. So, teleoperation is one mode of control where the loop is made very fast between a user that manipulates a master arm and a slave arm that executes at a distance the task. Meanwhile, through a screen, the user can see the image that is captured by an imaging device. So the distance can be quite high, but again, the slave arm that does the task is under full control of the distance operator. This is the first implementation of collaborative robots. A second one is realizing the task at the same location. So the robot and the user are now at the same location, and they collaborate mechanically to do the task. We call that co-manipulation. And that can be done in a parallel fashion where the robot and the user both manipulate the same object and then force add. It can be done serially where we have that combination of movements in series. And we also have exoskeletons and orthoses. Today I will talk about two main medical applications of those collaborative devices. One is for so-called laparoscopic surgery, and one is for prosthetics. Okay, I start with laparoscopic surgery to show a first application. And this is this surgery that you have where to operate a patient, you don't fully open the whole body, but instead you insert small cannulas, and through the cannulas you can insert instruments to do the operations. So the operating surgeon here is with these two instruments here. Oh, I have here and here. Oops. And so the two black instruments in front of us are the operating surgeons, and the two other hands are an assistant that holds the cameras and probably a retractor or maybe a cleaning instrument. What they see is seen on the right view. They see in the screen inside the patient, and under that view, they can control the instrument. That surgery is quite efficient, but we know that it's quite difficult also for a surgeon to do complex operations, and the application is often limited to small, simple medical interventions, whereas it could have benefit if used for more complex operations. So you probably heard that robots have been introduced in the US for at least 20 years, and this mainly, the main robot that is used is an American robot. It's called Da Vinci, and Da Vinci can perform teleoperation inside the patient. So the instruments that you see here are inside a patient. The arms manipulate the instruments from outside the patient, and the surgeon is at a console. It has It has a master console that to control those instruments. It has also a 3D view and all the control of the instrument flexibility. This is, in reality, by far the most successful robot so far in the medical field. And it has been used for millions of operations all over the world. However, today, we know that we have a few concerns about that paradigm. One is that the cost is quite high. The safety is also an issue because, in fact, there is no force feedback on the side of the surgeon, so the surgeon doesn't feel the forces that he applies. Rather, he can only see the movements of the instrument, but only the distal movement of the instrument. So the rest of the movement of the robot is not under the survey of the surgeon. And we call that a problem of situation awareness. He's not aware of the whole situation, he's only aware of the tip instrument location. So to cope with this problem, there is more and more another paradigm that has been developed, and this is the concept of co-manipulation. So in fact, instead of having a robot that does the whole operation and a person that is at a distance to control the robot, we want to mix mechanical movements, robotized movements with human movements all together on the site with the patients. So mechanical attempts have been made in the past where instruments, mechanical instruments have been fabricated that can be manipulated by the surgeons to provide, for example, inner dexterity inside the patient from outer movement. And this has been a paradigm that was aimed at replacing the dexterity that was provided by the Da Vinci robot, but at a lower cost. So many different attempts have been realized, but the general problem that has been observed with those instruments is that their manipulation is not easy. So the surgeon has a learning curve to understand how to manipulate the controls to do the inner movements of the system that were not intuitive. And if you give an instrument to a surgeon that is not intuitive to use, well, the surgeon simply does not use it. You know, he prefers to refer to the old instrument. One quality of the Da Vinci system is that its manipulation is very intuitive. So how robotics can help to solve that problem? Well, instead of having mechanical coupled instruments, we can imagine to have robotized instruments where the distal movement of the instrument is controlled by small actuators, and these actuators can be mapped into whatever control of the human system in such a way that it becomes intuitive. It's not constrained, it's constrained by mechanical relation mapping between hand movements and distal movements. So we have been, for example, studied that problem, and to do so, one interesting concept that can be used in modern robotics is what we call virtual prototyping. One problem that we had in studying that question is that, so we want to fabricate robotized instruments to do surgery. The problem is that prototyping a real instrument with several degrees of freedom within a 5 millimeter diameter rod is quite a long and complex task. Now, if we design one robot and we want to test at the end whether its use is intuitive, it's very long in terms of time and the cost is very high in terms of research and development. Meanwhile, we can fabricate virtual prototypes, meaning that the prototype does not exist. We just fabricate a handle with buttons, and these buttons, they control a video game. And the video game is the virtual instrument in such a way that you can give the instrument any different kind of movement or mobility that you can imagine. It's very rapid to develop one. It takes 1 day instead of 2 years. And then you can test that with different subjects to see whether the controls that you provide to the user versus the mobility that you give help in doing a task that is representative of surgery. So we have done this, and we went through, at the end, the design of such an instrument, and we were very happy that a startup company decided to industrialize that system, and it's now a commercially available robot. So again, it's simply handheld robots, has specific controls here that were optimized thanks to our research, a specific mechatronic design to give 2 degrees of freedom that were selected again by our design, and can perform the surgery with specific motion that are not achievable by standard instruments. I want to say that the price of this robot has 3 orders of magnitude lower than the price of a Da Vinci robot. Okay, so you can see here the curved instrument and the distal mobility that was implemented on the system. So really we have the concept of co-manipulation in that sense that the distal movement is a combination of the hand movements and some actuators that were optimally positioned into the system to provide the missing mobility inside the patient. Of course, we also have a question in holding, for example, an endoscope. So this is an endoscope that is used for laparoscopic surgery. And we have designed collaborative arms to manipulate this kind of endoscopes. So in the previous talk, it was said that the compliance of the system is very important. Of course, we want to have a robotic system that does not exert large forces because it inserts an endoscope into a patient, and we want to avoid large forces to be exerted. So thanks to good transmission technology, thanks to good control, impedance control, which is the same method that is used in the KUKA EWA robots, we can have a similar behavior with a very high compliance of the system, and yet, thanks to some advanced control, for example, to compensate the friction, we can have a quite good dynamic and static precision. Such robots that are used to help manipulation of an endoscope, they can also help manipulating an instrument. So here you have a surgical instrument, which tip can be observed here with the endoscope. So you see the tip on the screen on the top left. And this instrument is inserted into a mock-up patient, so with trocars. And whenever we stop moving, the robot understands that it should stay at the same location and freezes automatically the system, locks to that position. And whenever we pull the instrument, the system freezes. So this is Professor Gaillet, our surgical colleague, using the same robot here so as you can see, he's inside a pig. He lifts part of the liver, which is called, with an instrument that is called a retractor. And whenever the liver is lifted, he just freezes his motion for a few seconds. You will see that. So freezes, and then the robot automatically understands that is the correct position. So it will compute automatically the force that are needed to maintain that liver up and allow the surgeon to use his other hands to do the operation. So again, what's interesting here is that the device has all the dynamic and mechanical properties that are useful for the task, but they are also intelligent in terms of, in that sense that they understand the user intention, but it's either moving or locking automatically without any additional buttons or without any additional interface. And this is probably how we are going to reach what Heiner was called physical intelligence. Okay, I want to switch now to the second part of the topic, and this is about prosthetics. Okay, so prosthetics is another part of the robotics today. It is aimed at replacing the limbs of an amputated person or the part of the limb. So we know that today most of the prostheses that are used worldwide are passive prostheses, and for example with that runner we have a very high performance. I mean, this runner has a left leg that has the same performance as the right leg when she's running because of the nice mechanical property of this passive device. So we can reach high performance with a passive prosthesis, but how about versatility? In fact, versatility is very low. For example, that prosthesis has been designed specifically to optimize the running task. But if she wants to do something else than running, like being at home, like walking in the street, like being in a place where there are stairways, they have many different shapes of prosthesis that they have to switch depending on the context. Passive prosthesis can be optimized, but they cannot be as versatile as a human limb. And this is why robotics has been, or devices with mechanical mobility has been used to change the configuration and to adapt to the situation. So here we have an example, a very old example of a mechanical arm used for an arm amputee. And the system has cable, and the system and it is mounted in such a way that with the elbow here, with the shoulder here, when moving the shoulder, the cables are moved, and you can obtain some movements with the right prosthesis. So maybe one could think that this sort of device is archaic, but I want to say that it is quite some of the best solution we are. And to show that here, I have extracted that video. So it's a video that was extracted from a competition for people wearing prosthesis, and this competition is called Side Afro. So the guy that you are seeing here is asked to do several tasks with his hands, and several tasks that represent daily tasks. And the champion that is here won the competition against all the robotics competitor, although his arm is just a simple mechanical arm, just the very old version. So with the very old version of the system and only cables, today the performance is better than what we can do with robot. And the question probably is why. So why can he do this? Because he's very motivated and he can learn incredible skills even with devices that are not optimized, because humans adapt to the system. So this guy is an extraordinary champion thanks to the training that he made with his device. So we are trying to, the general community is trying to develop systems that are motorized and robotized. So one of the most popular way to do that is to do myoelectric prosthesis. So it's a prosthesis that has electrical motors and batteries inside, and that are connected with myoelectric sensors to the human limb in such a way that whenever you will contract the muscle, it will move the robot. So maybe that can seem more modern than the cable thing. But in fact, this idea was already in the street like in 1964. So this prototype was built and was working in 1964 and uses myoelectric control. So it's not a very recent idea. And if we look at today's, the state of the art with that approach is robotic devices that have many degrees of freedom, in particular hands, multi-figured hands that can do many different, that you can control to get many different configurations to perform different tasks. But the control itself that you give to the patient is very, very, very archaic. The control is made by EMG, and it's like a Morse signal. In other words, what you ask to the subject is to give some impulse to the muscles, some digital signal, like 3 pulses here will correspond to move the hand in that direction. 2 pulses, and then the co-contraction will correspond to change the mode to this and this. So there's just like sequences of contractions that will give a set of discrete movements that have been programmed to the robot. And using this to perform tasks requires a very, very long learning today. And most of the time, it is too cognitively demanding, and people give up the use of those prostheses. Also, the mechanical solution is fine. The control solution is misleading. So one of the reasons is that electromyographic signals are not of good quality, so we cannot interpret them in real time very finely with a high robustness. So people try to use different connections and to go deeper into the muscles and the nervous system to get better signal. And this is more invasive, but it improves a bit the quality of the signals and allow a little better control. Still, it's not perfect. So people sometimes try to do surgery. So here you have an amputated guy who got surgery. And during the surgery, they had all the nerves redirected into this area, where you can put a lot of different EMG sensors to measure the activity that is spread by all the nerves that have been put there. This gives a high redundancy signal, high dimensional signals, and if you do learning and learning and learning, you can learn how, for example, to move or to even to feel things with those signals. So it gives a better control, but it's a very, very tough surgery, a very difficult surgery. The success rate is not super high. And again, the learning is so long that it's not accessible to most of the population. So what we are doing here in our lab is something that is try to avoid long learning to do a combination of human movements and robotic movements. And I do that with my colleague, Nathanael Jarasek, who is on this picture. And I want to show 2 examples of what we are trying to do to improve the intuitiveness of the combination of human and robotic movements and to help users to use the prosthesis much more easily. So the first example is using phantom limb phenomenon. Phantom limb phenomenon is the phenomenon that when you are amputated, you still feel that a member is here. The member is not here anymore, but you can feel that it's here. And you can even mentally move it. So if you ask like 80% of the amputated people, if you ask them to move their limb, they can close the eyes and they really feel that they have a limb that moves and they can move it. Meanwhile, if you ask them to do this and you measure the electromyographic activity here on the remaining part of the limb, you will measure an activity. This activity corresponds to the fact that they are controlling mentally their phantom limb. So what we have done, obviously artificial intelligence is one of the key technology to achieve those coupling. Thanks to AI, we've been able to ask people to mentally move their limb, open the hand, close the hand, move the elbow. So they were doing this. Meanwhile, we were recording the signal. And thanks to automatic classification and artificial intelligence techniques, we were able to recognize the signal of their own movements. Not just a signal that asking them to have a sequence that were predetermined, but to adapt to their own control system and their own muscular structure here in the remaining part of the game. And being able of doing so we have, this is what we require. We do some signal processing and classifications, and we were able to detect up to 97% of the correct movement. So here, the guy that is here, for some technical reason on that video, the prosthesis is not mounted on the patient, but here we are using this to ask the subject to perform that task, which is simply manipulating object and doing these movements. You must know that this person was trained for only 5 minutes before that video to learn how to control this and doing this. He was just asked to move his phantom limb, then we were recording, we were post-processing those few trials, and we connected directly this. And we had a success rate of 95% only from those 5 minutes learned. This is definitely how artificial intelligence will help us understanding people's movement intention and connecting that to robots. I'm sorry, I'm lost. Here we go. Now, the last example I wanted to show is what we do in another kind of intuitive control is measuring the reaction of people who wear a prosthesis when the prosthesis is not working properly. So I will go directly, because I don't know what time I should accelerate, so I will go directly to the video that explains. Here you have a subject, and we ask the subject to follow the movement of the robot. So the robot draws a square here in space, and the subject is asked to follow that square with that end effector that was mounted on his hand. So this is a natural movement. Everybody, most of people can do that. What is going on? Okay, now I want to show what happens. We are asking the same guy to do the same task, but we have added a robotic device that at this time locks the elbow. So the elbow is always 90 degrees like this. The elbow cannot be moved by the subject. It is imposed by a robot, just like if it was a prosthesis, okay? And what you can see if you compare those movements is that when the first subject, during the first experiments, the torso stays straight, but it's in the second experiment, because this is locked, the torso is bent towards the task in order to achieve the task. This is called body compensation. So when the subject wants to do a task and the limb is not working appropriately, the subject naturally compensates with the body to achieve the task. Now, knowing this phenomenon, which is highly described in the literature, we can measure the body compensation and say that if the subject bends, we should extend the arm. And this is what we have done here in this last experience. Again, the subject here is asked to follow this, and we don't tell him how the robot moves. Simply, whenever the subject tries to bend a little bit, the robot will expand. And whenever the shoulder is on the back, the elbow will do the reverse motion. So what you have here is a subject that realizes the end effector task, is concentrate on this. The robot here doesn't know the task, but simply on observing the movement of the body of the subject, knows how to adapt in such a way that the movements are combined. Again, I want to emphasize the fact that the subject was not taught how to do that. He has no idea on how the robot controls the system. He was only asked to do the final task. And this is what we are trying to do when we try to combine robotic movements and human movements, is that intuitively the robot performs what the subject wants without any specific intention declaration. Okay, so I think I should now conclude. I just wanted maybe to show that other video, which is exactly the same. So if you remember the first video I've shown in that side action loop, we are currently, which will be held virtually mid-November. And one of the tasks is this one. And I just wanted, so here what is happening is that this robot is moving the hand autonomously, simply measuring the inclination of the user. And the user can do the task without any knowledge on how the robot works. And we have even tried this with public visiting the lab. So we had an open day. All the public could try this, and they were all able to perform the task quite naturally without any learning. Okay, in summary, what we are interested in combining human motion and robotic motion to realize tasks in such a way that you don't have any complex programming, and that the robot understands the intention, understands what is happening, and adapts its behavior or its trajectory. Okay. Maybe I can join Rainer Bishop's conclusion here. Like the real trend is to have robots that become collaborative because they can have a much more versatile task to realize. They need to behave safely to understand human intention. They need to show what they are doing. You need to be aware of what they are doing permanently. And this is quite a fundamental question, because if you want the human to accept the presence of the robot, must be very clear about the situation. And we are at the time where we can close the sensory motor loops of the robot with the human, meaning that there is a real-time loop for the two systems. Well, I guess this will conclude my talk. I was very pleased to talk with you. And I just wanted to mention, because it's an opportunity, if there are any PhD students that are finishing currently in Croatia, I've been visiting Bojan Jerbić laboratory last year with the invitation of the French embassy, and I'm quite aware of the very high quality of the research in robotics that is made in Bojan's laboratory, but also in Croatia. And I would really be very pleased to receive the applications for PhD students who want to do postdocs here in Paris. Please drop an email if you're interested.
Thank you very much, Monsieur Morel, for this extensive and thorough presentation, and thank you for the invitation for our prospective students. I sure do hope that some of the Croatian students will come to your university to fill up that position. Thank you so much for finding time for us and for being here with us virtually today. Have a great day.
Thanks.
Bye-bye. Nažalost, nismo imali vremena za pitanje, no vjerujem da će biti još prilika za to. Vjerujem da ste uživali. S ovim istaknutim plenarnim predavanjem došli smo do kraja ovoga dijela, stoga vam hvala najljepše što ste ostali do kraja na ovom svečanom otvorenju 43. po redu Međunarodnog skupa MIPRO. Prije nego što izađete vane, samo nekoliko informacija. Kako bi se skup odvijao neometano, molimo vas da cijelo vrijeme nosite bedževe oko vrata i da poštujete dakako epidemiološke mjere. Ukoliko imate bilo kakvo pitanja vezano uz skup, slobodno možete postaviti to pitanje na recepciji skupa ili pitati neku osobu koja ima bedž sa oznakom organizator ili neku od naših hostesa. Profesor Skala već je bio najavio koktel koji je organiziran za večeras u 19 sati i 30 minuta i to u kongresnom dijelu hotela, a sada je pauza za ručak. Stoga vam želim dobar tek. U 15 sati točno ovdje kreću 4 plenarna predavanja, stoga nemojte zaboraviti doći. Hvala vam najljepša još jednom što ste bili s nama i vi ovdje u dvorani, ali naravno veliki pozdrav i svima onima koji su nas pratili online. Doista se nadamo da će sljedeće godine ovo svečano otvorenje biti u onakvom obimu na kakav smo i navikli. Ugodan ostatak dana vam želim svima. Čuvajte se, ostanite odgovorni i zdravi. Pa pa!